Welcome to the first lecture on regression analysis and forecasting. In this lecture, we are going to learn the basic fundamentals. There are very small topics, but these are the topics which create the background to learn the statistical tools related to the regression analysis later on. So, in this lecture, we are just going to learn the small topic, the basic fundamentals, which will help us later on. So, well, if I ask you, what is a model? That is my very basic question to all of you. You see, the model is nothing. This is only a mathematical representation of a phenomena. What do you mean by this? This is nothing but a mathematical representation of a phenomena. What does this mean? For example, when you try to conduct an experiment, you know there is a process which is happening, and in that experiment there are two types of variable. One variable which is an output variable, and there are some variables which are causing that output. So now, in case if you try to find out the relationship between the input and output variables, that will be called as a model, right? So essentially, model is nothing but this is simply the representation of a relationship. Now, let me take a very simple example to explain you. For example, if I say yield of a crop, yield of a crop depends on several factors, like as quantity of fertilizer, quality of fertilizer, irrigation, rainfall, temperature, and so on. So, for example, let me take here this some variables like as quantity of fertilizer, irrigation level, temperature, and so on, right. Now, in case if I try to find out a mathematical functional relationship between these three variables, quantity of fertilizer, irrigation level, and say temperature, then this will be a mathematical relationship between yield of crop and these three variables. Suppose if I denote it by here y, suppose quantity of fertilizer, this is suppose denoted by say some variable x1, and suppose this is measured in kilogram. This irrigation level, let us try to denote here as say x2, and this is measured in say centimeters, and temperature, let us try to denote by here some other variable x3, and suppose this is measured in degree centigrades. So one possible model can be y is equal to 2x1 plus 3x2 plus say 4x3. So this is what? This is a mathematical relationship between the output, which is the yield of a crop, and three input variables, which are your quantity of fertilizer, irrigation level, and temperature, right. Similarly, if I try to take this another example, suppose if I say dose of a medicine. Dose of a medicine means whether a patient has to be given half tablet, quarter tablet, or a full tablet, or 2 tablets. That depends on several factors. And one of the important factor is age of patient. Second thing can be his health conditions, which can be determined by different variables like as blood pressure, blood sugar, or say some other variable. So let us try to assume for a while that the dose of a medicine depends on the age of the patient and blood pressure, and when we try to find out a functional relationship or a mathematical relationship between the dose of a medicine with respect to age of patient as well as blood pressure, then this will be a sort of mathematical model, right. For example, if I try to denote this dose of medicine by here y, age of patient by here x1, and blood pressure in say x2 with some appropriate units. So for example, if I try to write this is 3x1 plus 4x2, or that can also be something like 2 plus 3x1 plus 4x2. So these are simply mathematical equations which are trying to represent a relationship between the input variables and say output variable. So they are essentially a model. Now, once you try to see in this model, there are two types of component. One is input variable, or they can be more than one variables, and there is an output variable, right. So, we will try to denote the output variable by here y, and the input variable, suppose if I say there are p variables, so we can denote them by here x1, x2, say xp. So, these are your here p variables which are affecting the output y, right. Now, what is your objective? The objective is that we want to find out a relationship between x1, x2, xp and y in a mathematical framework, right. So, now the question is this: what is this model representing? This model is actually representing some phenomena. For example, if I say take the same example of yield of a crop, the yield of crop that is happening, that is being controlled by irrigation level, temperature, quality of fertilizer, quantity of fertilizer and so on. We have no control over it. And there is some mathematical relationship which is existing in the nature. The problem is that we don't know that relationship. And our objective is that if somehow I come to know about this relationship, possibly that will help us for the better future and say better planning, right. So, now there can be two things. Suppose I say that this is my here model. So, now this model can be a good model, or this can be a bad model. What do you really understand by a good model and a bad model? In a very simple sense, I can say a good model will be a model which incorporates all salient features of the phenomena. For example, if I say that in the model for yield of a crop, for example, in this case, if I try to take the same thing here, that yield of the crop, this depends on quantity of fertilizer, irrigation level and temperature. Now, suppose for a while you say, well, means I try to find out a relationship where yield of the crop depends on some factor, and we say we are not considering this quantity of fertilizer. Do you really think that is it going to be a good model? Not really, because we all know, we are the social scientists and we know that the yield of a crop depends on the quantity of fertilizer up to a certain extent. Right. So, I can say here that, that in case of a good model, I would like to have that all salient features of the phenomena are incorporated. Right. The next question comes, well, I would like to have a good model, no doubt about it, but then how to obtain it? Right. So, for that we try to collect a sample of data. Right. Once, how do you say what is sample? That is the basic question. You see, sample is nothing but this is a fraction of a population, a small fraction of the population. But this needs to have one very important characteristic, that we assume that sample is a representative sample. This is essentially a representative sample in the sense that whatever are the features available in the population, they are present in my sample, right. So, by representative means that all features of the population are present, right. Okay. And now as a statistician, how do we start? We try to collect the data. We try to conduct the experiment, or we try to observe the phenomena, and we try to collect the data. Now, one thing which what you have to keep in mind, which is very important, that as a statistician, we have no right to change the process. Whatever is the natural mode of happening of a phenomena or an experimental process, that would continue. Right. So, now what you have in your hand before you start? You simply have a small sample of data. The data can be of say 20 observation, 30 observation, 100 observation or 200 observation, depending on the situation. Right. So, now let us try to consider another aspect of a model. A model has two components. One is variables and another is parameters. Now, what is the difference between a variable and a parameter? Let me try to explain it in a very simple and layman's language. You all have learnt this equation in your possibly in class 12 or say class 10, something like this, y equal to mx plus c. What is this? This is an equation of a line, right? Now, there are four components here, x, y and m here c. So, let me try to group them into two groups, x, y and say here m and c, right. We all know that this equation, if I try to draw on a graph, if this is something like a line, this I know this is my here x-axis, this is my here y-axis, and this is my here line y is equal to mx plus c, and this distance is here c, and this is here the slope, which is represented by here m is equal to tan of theta, right. So, now let us try to consider this line, and now I ask you one simple question, right? And or if I write two statements here, and let me try to explain which of the statement is correct. First statement is knowledge on x and y completely describes the equation. Or the second sentence is this, knowledge on m and c completely describes the equation, because at this moment we are considering a simple equation. So, the second sentence is that knowledge on say m and c completely describes the equation. Now, what do you think? Which one is correct? Right. Can we take a simple example? Suppose if I say x is equal to 2 and y is equal to 3, and suppose m equal to 4 and c equal to here 5, right. Now, once I try to consider here this statement number here 1, so knowledge on x, y is known to us. So, I can write this model here 3 is equal to 2m plus c. And now, in case if I try to use here this thing, the second statement, then I can write down here y is equal to 4x plus 5. Now, I have here these two equations. Now, do you know or can you say that which of the equation is completely describing the line? Well, I can see here this is not describing a line, because these are the values of m and c which are unknown to us, and this is only telling us that there is one pair of point, this is 2 and 3, that is all. On the other hand, if you try to consider this equation, this is telling us everything about the line. This is giving us complete information about the line. It is telling it that the intercept term here is, intercept is equal to here 5, and the slope can be controlled by here the value 4, that will 4 is equal to tan theta, because the slope is tan inverse 4, right. So, now once I know the value of m and c, I can always find that for a given value of x, what will be the value of y, or for a given value of y, what will be the value of x, and all information about this line is completely known to us. So, broadly speaking, here I have here two sets of values, x and y and say m and c, which I am marking here, x and y and say here m and c. And we observe that by knowing the value of m and c, I can determine the complete line, whereas just by knowing the value of x and y, I cannot know the entire line. So, in a layman's language, I can say that x and y are my variable and m and c are the parameters. So, parameters are essentially the component of a model which determine the entire equation, or in our language, parameters are the component of an equation which describes the complete model. So, whenever I say that I want to do a modeling, that is a very simple sentence, that I just want to know the values of my parameter, that is all. So, you have heard many people say, okay, if we want to do the modeling, and modeling is this and modeling is that, but now you can say that modeling is nothing but just knowing the values of the parameter. Now, but then what is the hurdle in obtaining a model? The hurdle is that parameter values are not known to us. The question is how to know them. Once I know the parameter value, the entire model is known to us, right. So, in statistics, I would say that whenever I say that I want to do a modeling, this means what? It simply means I want to know the values of parameters. So, question is that how do we know it? They are unknown to us. They exist in the nature, that is okay, but we have no idea. So, in this case, the statistical tools help us. Now, there are different types of statistical techniques which can help us in finding out the values of these parameters. And among those techniques, we are going to use here the technique of regression analysis. Right. And this regression analysis tool will help us to find out the values of the parameters on the basis of a given set of data. So, there are many statistical tools which help us in knowing the value of this parameter, and from those techniques we are going to use here the regression analysis technique. This regression analysis technique has an advantage that it helps us in finding out the unknown values of the parameters on the basis of a given set of data, and this data is obtained from some experimental settings, from some experiment or from some survey and so on. So, here we stop and we will continue in the next lecture. Thank you.